Welcome, everyone, to episode 14 of the Intersection 4 podcast. You have your three usual hosts here. You have Hamis Investor, you have Brendan, the founder, and you have me, the philosopher. And yeah, we're excited to see you guys again. It's been a bit of a bit of a couple of weeks since we last posted our last episode. We're back at it. Excited to bring a new episode for you. We're going to be discussing two topics. And if things usually go the way that they usually do with our conversations, then we just get to one topic, but hopefully we get to both of them. But one of those topics, and the first one that we're going to introduce, is limitations of AI agents. I think it's timely. We're seeing a boom on AI agents, but there's discussions around whether this is just hype, whether there's substance behind it, how much can AI agents do, what are the limitations that they have right now. And I think it's interesting to dive a little bit deeper into this. And if we have time, at the end of the episode, we're going to talk a little bit more about meme coins. We are living through the craziest meme coin bull run that we have seen probably since 21, maybe even before that. And a lot of money is being made, a lot of funny money is being tossed around, and it's worth also a deeper discussion as well. So, without further ado, let's jump into the AI agent topic. I'll pass it on to you, Hamis. This was your idea. This was your proposed discussion topic. So, explain to us where do you want to take this conversation. What are some of the things you want to ask our expert witness here on Brendan, our AI expert?
Yeah, absolutely. Thanks for the intro, Sam. So I actually first heard about agents from Brendan on the podcast. I think this was when you had just come back from the summit, from the OpenAI summit, and you were talking about, hey, like everybody there is like super focused on agents, like that's like the next wave of startups coming out. And so I'm by no means like an expert on the topic. I'm very like curious about it. I've been learning a lot about it. And we've been internally, testing and trying to wrap our heads around it. But in simple terms, the first um, mainstream use of these models was to create a chat interface where you would ask questions or pose prompts and you would get chat responses. But the models behind it couldn't do much more than that. They were kind of restricted to this text environment, or if they went beyond that, it was still kind of like a one-way street where you would get video or text or images, but they weren't really able to push something beyond that. But the main attraction of agents is that they're able to do a lot more than just give you back text or content of some type. And they're able to actually do some of the functions and some of the processes that a human might be able to do. And so it's a fascinating topic of how these models can now be used for much more complex and impactful applications that go beyond just sort of like content creation in civil terms. Um, but there's, just like with most of these really big changes in technology, there's like two camps. There's a camp that thinks that the whole world is going to be different moving forward, and uh, this has very serious implications for the world. And there's another camp that feels that the impact or the potential is a little overblown. These agents are still very simplistic in what they can do. So what I really want to focus on is getting into the specifics of what might um, make these technologies limited and what might be misunderstood on how much they can already do. Because I think naturally people either overestimate it or underestimate it. Any technology, I'd like to get us to like accurately estimate its potential, like somewhere in the middle, is usually where it is. So I couldn't think of a better person or a better group to have the discussion with. So first question to Brendan would be, um, help us understand what you feel is today the most likely use of these agents, and maybe you have some examples in front of you, and then we'll take the conversation into some of the limitations for what you see today.
And
Yeah,
maybe just for context too, even if you take a step back and just give a quick one-on-one two
definition.
sentence definition of what an agent is.
Yeah. Yeah. So I think we've There's no right definition. There's a useful definition, I think, for our conversation, and it's that an AI agent is the next generation of what today we call copilot workflows. Copilot workflows were kind of the first valuable use case on top of these large language models. These large language models ate a bunch of the internet's text. You ask a question, it spits out an answer. If you were to run that in a loop and say, here's an objective I have, can you spit out an answer and then spit that answer back into the large language model and try to assess, was that the right answer? Continue to refine that. That effectively is like the simplest version of an agent. It has some level of perception, which the simplest form is text, some action it can take to generate more text is the simplest form, and then some architecture, which is typically an LLM, which is recursively or in using some methodology continuing to re-ask that question or use tools or re-perceive the world. So there's variations of this, but we're now moving from Copilot, which is human in the loop with the agent or the LLM assisting users, into these agentic workflows where there's effectively an objective function the user sets, and they are using at their disposal some perception functionality. Hey, can I retrieve the current weather? Can I retrieve the current text input, the screenshot of the user's browser? And then can I take an action? Can I order a pizza? Can I send an email? Can I write a draft report? Those are the kind of primitives that we're kind of building up right now. The typical agents that are like in the wild right now have fallen into mostly a sales bucket I've seen. These are well understood problem sets. They are repetitive in nature. They are not mission critical. If you send a poorly written outbound email to a prospect, you're not going to get dinged for it. We're not in the medical industry or legal industry or fintech. So I think a lot of that has allowed people to build quite quickly to test these in the market and then improve them. The APIs are well understood. You have your HubSpots, your LinkedIn's, your Google ads. So for some of those reasons, the kind of the agents that have found their way to success have typically been in these sales BDR style roles, but they're starting to creep into other industries as well. That's a short.
So
Okay.
what would be kind of the difference then between automation? Because the sales automation tools have been there forever, right? You can
Yep.
create kind of a flow, send an email to this person using these
Yep.
keywords. If they don't respond 10 minutes later, send them another one. Are we saying that it's like a next version of automation, or is it like something completely different?
I think that, yeah, the definition falls on the team. You might argue actually that some humans maybe aren't even the AI agent level. Some humans might require any deviation from the path that they're supposed to follow requires them to go back to their manager and say, hey, what do I do given this happened? That is effectively a lot of these like workflow automation tools or what is it, RAT, or there's some word for it for the
RPA.
RPA, yeah, RPA tools over the last 15 years that have found their way to success. Yeah, it's basically a graduation from RPA to dynamically defined RPA. And that level of guardrails is what makes them valuable. That also is what makes them constrained or not valuable in many cases. So for a lot of industries, we want guardrails over the RPA workflow, the agent workflow. For other industries, it's more valuable for it to be open-ended and for the agent to make some of that decision-making process. I think there's a open question of how much of these workflows can be truly agentified, given that a lot of the business process is not a right or wrong answer. It's an opinionation. So I think a lot of people found success in using RAG, retrieval augmented generation, to seed what is the right workflow to be done, given historical telemetry. So if you have 1,000 reps that have emailed people in this fashion, you don't have to tell the system, hey, when you come across someone in fintech in the New York region, I want you to use a Boston accent or whatever. You might just say, okay, I pulled in all of the semantically similar conversations we've had to reps in this region, and there was a Boston accent, so I'm going to go ahead and use that as the workflow definition or instruction set. Yeah.
Brandon, I have a question here. So help me understand this. Let's say you have an arbitrary task, and that task involves calling a certain amount of APIs in a given order, and then you need to take some action on those APIs, and then you get a specific outcome. Let's say you're able to define that entire workflow, right, for the agent to take. What needs to change at the agent level, at the model level, I guess I should say, for the model to be able to interact with those tools? And maybe instead of one step is not an API, one step is actually going and clicking on some buttons in a given browser. And then based on that information, calling an API and then making a phone call or whatever. But let's say the steps are well defined. How does the model itself need to be either fine tuned or pre trained on some specific data to be able to be adjusted to use those tools that are defined in the workflow?
Yeah, I think that I simplify it down to 3 steps: a perception problem, an architecture or an intelligence problem, reasoning, and then actions. The simplest one is perceive. Do you have access to the browser, text input, sensory data to actually perceive the environment? Do you have some reasoning functionality through an LLM, through a predefined set of if this, then that? It doesn't have to be a language model. It could just be an if case statement. And then action. Do you have an API endpoint that you can hit that is defined and like available to take that action, generate text, send email, draft query? Those 3 are basically the 3 kind of setups that you need to have. And then the game is just give it better perception, give it better models for the reasoning engine part, and then give it more tools and actions. And then the rest is a business SOP, right? Standard operating procedure.
I
Yeah.
love that simplification. That's really good. Would you
Yep.
say
And this is a human too, right? Like this is not
Mhm.
yeah,
just
yeah,
agents.
yeah,
This
yeah.
is like any, and you don't even have to find this as an agent. This could just be RPA. There's a perception, there's an architecture, and an action. RPA though, the architecture is codified. The
Yep.
agent, we've just non-codified the architecture.
Mhm.
Yeah,
Yeah.
okay, this is good. And what would you say? So, if we were to answer kind of like the title of the opening theme, where is the limitation? And I love that definition of perception, reason, and action. Do you, would you say the limitation is at the perception aspect? Like, how do you perceive the world to be able to take a given action, or where do you think is the limitation here?
Depends on the industry, depends on the workflow. I'll give you an example.
Yeah.
Perception is extremely hard for self-driving cars. Reasoning and architecture, extremely hard. The action is there's a fixed set of actions. Turn the car left, turn the car right, uh, push the pedal faster, hit the brake. There's 7 to 8 actions that can be taken. And based on perfect perception, perfect reasoning, the action is actually quite simple. I think there's other workflows that the number of actions you could take are insanely high, and that would not be the case. There's other ones that I think perception is like a solved problem. Reasoning might not be, or the action might
Mhm.
not be there at all. So it's extremely business specific and industry specific as
Mhm.
well.
Mhm. Yeah. Yeah.
What
That obviously makes a ton of sense. Help us understand because when one of the things that I've seen from the partners or the technologists that we work with is they're quick to kind of brush it off as a overly hyped RPA function, and I think it's because they're looking at version 1 of the technology and they're saying, oh, that's not so great, so it'll never be great. Um, how do you get past that point? Like, what needs to improve? Not just use case specific, but like, what are the main places that you think are the easiest to solve in these 3 buckets, and like, what are the more difficult things to solve in these 3 buckets?
I think I think it's too specific to like a
Okay.
use case, but
Okay.
I will say like the most value that I've seen out of companies is through UI, user interfaces, right? You can deploy a better model, give it more context, which is effectively the reasoning part and the perception part. But if it is not transparent to the user, the same way that if I were to hire a new employee, I always like to just translate this into like a human equivalent. I hired a
Mhm.
really smart PhD, and I gave them our entire code base, all my emails, all of our Slack, our Google Drive, our S3, all of our company data, and I gave them a really hard task, and they come out and say 42 is the answer, right? You need to go do this one thing. I can't do anything with that. I don't know. Are they just really smart and like I can just go take that? But if they can walk me through using some graph, some here's what I did, then I did this, here's why I did this, and that some type of interface where they sit me down and they walk me through their thinking, that's valuable. Because I can then say, okay, wait, actually, this subsection, I didn't give you the details you needed there. Really, this is the new value. It's not codified anywhere. Here's how we need to adjust there. And then that, I think, is where people are able to see value. That's why it feels a lot like a co-pilot for a lot of use cases, is when you have 15 of those small like fix points, we call it a co-pilot. If you can do that entire workflow and you fix it once, that's kind of agentic. And the less kind of interventions you have, the higher trust and the more agentic it feels. I think that's where we're seeing a lot of value.
Hmm.
Have you guys used an agent, or like, is there one that you've experienced that you're like, yeah, this is the first version where I don't call this like an AI chatbot. I'll call it an agent.
Yeah. Yeah, we were, we have a lot of engineers on our team, and I love them, but I hate running engineering teams, right? It's just very, time consuming, expensive. Everything that I think is simple takes too long to build, right? Like it just takes a lot to run engineering teams. And so we've been experimenting internally on trying to build solutions that can make their productivity not 20% or 30% higher, but 10x higher. And where it really clicked for me was when I started seeing the agents speak to each other. That's when it was a little freaky, but that's where the light bulb went off. Because we've tried for many months to have them use Copilot and have them use other tools like that. But what I always felt that there was hesitation was that it took so much time to communicate with the model that after 2 or 3 attempts, the human would just give up in trying to explain what they were trying to explain. But where it really clicked for me is, we created a product manager agent, and we created a architecture agent, and we created a quality assurance agent. And when they were speaking to each other, there was no limit to how long they would keep talking till they got the requirements down, right? And they got the quality down, and they got the code base down. And so that's where it really clicked for me, is because I always felt that the fatigue that humans have with communication would be the limitation. But what if it was one agent speaking to the other one, making sure the other agent understands and not stopping until it does? That's when I was like, okay, so I could be sleeping and they'll run 50 sprints while I'm sleeping. And then when I wake up in the morning, they would have solved the problem. So
Yeah.
that really kind of did it for me.
What
Yeah.
what came out of those agentic conversations? Like what was the objective that you defined here? Was it like documentations, requirements for a product, or what exactly?
No, we said, make me a calculator. And then there was a specifications agent that wrote down the specifications and passed it on to the architect agent. The architect agent wrote down how the architecture should work, what technologies they would use, and then passed it on to the QA agent. The QA agent wrote all the unit tests and the acceptance criteria, then passed it on to the developer agent. The developer agent wrote the code, and then the QA agent tested it, and they kept going back and forth until all the tests were cleared, right? And it was freaky because they were telling each other, "Oh, good quality code, good work," right? And I'm like, you're a computer, right? Like, what are you guys doing? And so I agree with Brendan. Like, if it all had happened in the background, like they'd just given me a calculator, it would have been a different kind of
Yeah.
experience
Do
for
you,
me, at least. But when I saw them like talking to each other, the way a team talks to each other, that's when I was like, okay, this is weird, but this is interesting. That was really
there's
like
actually
yeah.
there's actually some reasons why and this has been a speculation, but there's some reasons why we believe that architecture works well. Because you call multiple agents, I'd call it one agent that like the architecture is to like break the problem up and then solve it using sub problems. But regardless of like the definitions, the reason that probably is a good architecture is the training data
Mm-hmm.
is that right? If you were to like take the corpus of the internet, a majority of the internet is a conversation between business
Mm-hmm.
units of people solving a problem together in Reddit, in GitHub, in a forum. And it's, hey, I'm John, I'm a data architect, and here's what I believe. I'm Todd, I designed it, and here's why I just don't agree with that. And I think that's why that architecture design has actually performed quite well. Is maybe because humans are really good at deciding how we organize each other, or it's just a shadow of what we are, which is the internet, and it's trained on all the internet. So if we architect it like the internet, then it's probably
Mm-hmm.
going to produce human-like results.
Mm-hmm.
That's a
Yeah.
good. I like the thesis. I like the thesis.
Mm-hmm.
Okay, so let's say, James, you went from building a calculator to build me an arbitrage bot to trade on these venues with the specific parameters, on these specific situations and the specific dates with this amount of capital, and give me this return. Point being, when the complexity of the task at hand increases, even if you have the same architecture, where does the system break? Back to the limitation discussion, right? So,
Mm-hmm.
what breaks first? Do you think in this architecture that you define? Do you think it's the product requirements that breaks first, the access to APIs that breaks first? I don't know, the QA, and why is that failing?
Mm-hmm.
I don't know if you have the answer for this. Maybe this is
I
more of a question
do.
for
I
Brendan. But
do.
where do you think this breaks when the complexity
Yeah,
increases?
I do, because like building a calculator app is not obviously the goal, right? The goal is to be able to go into a very complex business with a lot of history and be able to solve this problem for them. And so where we now are completely focused is on memory, because for an MVP, right, like memory is less important. But for the companies that we work with, some of them have been around for 40 years. They have 40 years of code and 40 years of knowledge and 40 years of best practices. And we need a way to have perfect recall and perfect memory of all 40 years to be able to be very, very effective. And so we have now come to the conclusion that the architecture that Brendan was, describing, we think the architecture works. We think that and we actually think the model and the reasoning is actually, we think, very good. Where
Yeah.
we feel that at least right now, all the I guess all the alpha is going to come from is how well we can figure out the reason, the perception part. Like how much perception can we give this, and how specific can it be to each company that we work with. And so we've completely shifted focus, and we're like, let's fix the perception problem. I wasn't calling it that. Brendan obviously explains it much better than I do. But we were calling it just memory. And we were like, okay, let's solve the memory problem. Because if we can crack that, it was writing perfectly fine code from what we see. But where it was lacking is after a couple hours of coding, it felt like it would start to forget the requirements, or I think it felt like it started to forget like what it had written before. Right. So it was more the perception problem is what we're really kind of focused on. The I think reasoning is very good, and the actions are the tooling. It actually would write the tooling itself. So it wrote the API connectors to whatever it needed to do. And the deployment, like we can still deploy pretty manually if needed, but we can't manually feed it all the perception because there's just so much. And so that's what we're like really focused on right now. And there's some really interesting stuff on that
Quick
as well.
follow up there, Hamis. Quick follow up. What model were you using for all these agents?
We used multiple, and we found that some of the, well, I'm not going to take like specific names, but like the non-OpenAI models were more effective,
Okay.
at least on the reasoning part. I
Any
think,
open source models you use? Just
yeah,
curiosity.
yeah, yeah. We
Okay.
used a bunch of open source models.
Okay.
I couldn't tell you specifically the performance, but there is information out there already on which of these perform best for
Yeah,
software
yeah.
development. So we're kind of going off of that. We haven't done any of our own benchmarking because again, like we didn't find that the code was bad. We just found that it was forgetting the context. So we're focused
So
on like fixing the context problem.
I think there's two things here that I think are interesting, two threads. One is memory as in context window, and then the second one is access to a search space as in RAG. And I guess it's more of a question for Brendan here. The memory piece of like you're working a given agent is going at a task for a very long time, and then the context window starts to basically shave off some of the things that were defined previously. The solution for that is just like a larger context window. It's not a trivial thing, right? That's like Gemini's whole thing is like a massive context window, um, but it's solvable, right? On the other side of access to a massive search space for generation of responses, um, I wanna get your thoughts here. Which one do you think to be? Which one do you think is more challenging here? Do you think the issue here is on the context window, or the issue here is on the access to a large enough search space for a specific use case?
I don't know. I don't think it's the right answer. I'll fall back to like again. I have I've hit agent roadblocks for both in multiple different scenarios. So the context window, it's again kind of another analogy which is helpful is computing. Like you can have CPU, you can have a RAM, and you can have a hard drive. And there's different scenarios where the person who's got a massive bank of knowledge, but their tasks are so constrained, small RAM, large hard drive, that's the setup that you need for that type of work. And you buy a different computer for a large, massive RAM. You don't need a ton of hard drive space because it's more compute heavy workload. And that's the same reason why we buy different computers is we would need different agent architectures, which is just a different setup such that you're at a good place to get the outcome. I think what is that's the non-answer I'll give. The other thing that I think people are thinking a lot about right now is that there's an issue with RAG. That there's an issue with context sometimes. We definitely don't know at runtime which one of those is going to be the problem or when you've hit that problem. And I think that is like a large body of work is going into like, when do you know you've hallucinated? When do you know you've pulled in the wrong context in your RAG application? Can you know that? Can you like say, hey, to the user, I'm 40% confident in my output because that was a massive amount of context you threw at me? Or, hey, I'm super confident in what I pulled into the context using RAG because everything else that was semantically similar was so far away in our dimensional space that like this is definitely what you're looking for. And any other issues have to be someone else's problem within the architecture. And I think it's like, how do you now inspect, debug, provide visibility to just the user or to like the developer who's building these systems? Because none of those two are solvable. But what is solvable probably is like knowing when you've hit one of those two limitations, or at least providing some guidance, right? Because like when I ask you, Sam, a very specific question about the latest blockchain, maybe you're like, yeah, I have this huge bank of knowledge, but the question you asked is so bespoke and specific that like I'll give you an answer, but I don't know if it's even remotely right. But you might have a different answer that you give me, which you're like, this is 1000% right. I can tell you when I give you the answer how right I am. And now I'm like, have to vet you on some other component of like the input output of an agent. So I think it's like, how do we start associating confidence in some level of risk of the output, not just did it answer or not.
Is that possible? Like, is that possible to get a confidence number out of the model as it gives you an output?
It's not trivial today. There's not like a company who's like, hey, we have LLMs plus this. I know Google does have some stuff for classification scoring. There's a relevance factor that comes out of most RAG applications, which is like a cosine similarity from 0 to 1. And you can use that as a proxy for confidence. There's a lot of hacks. And I think over time, the winners in the space are the ones who like figure out which are the best
Mm.
hacks, productionize those, and then really pull that into the into the future.
Is there a world in which that's just like very clever prompt engineering? It's like, hey, whenever you're gonna give me a response, give me a coefficient from 0 to 1 on how confident you are, and then you define what confidence is, and so on and
Mm.
so forth. And you give examples. Is there a world like because I've grown
Yeah,
a little intrigued by how many things with models can be achieved by just really clever prompt engineering. Is there a world in
yeah.
which this is one of those things, or is it just like I'm gonna hallucinate on my own confidence about my responses?
No, it is. It's easier, and this is like studied. It is easier for the agents or most LLMs to know if their answer was right or wrong than it is for them to generate the answer in the first place. Like there, you can show time and time again, generating the right answer is a harder problem than verifying that answer. So if you use by that logic, oh nice, we got a little background colors. By that logic, a lot of people use more intelligent agents to generate, and then they use quicker agents to validate. And that's an architectural decision that some teams make, and they can do that
Mm.
through an agent chain, through a self-corrective RAG application. And I think this, like, how do you com- turn into these components in these blocks? Because right, we've done this from day one. If you think of like computing, we didn't go and reinvent silicon every time we wanted to make a computer update. We said, given what's currently out there, can I stitch together a TSMC chip with an L3 cache with this, that in a NVIDIA GPU? And then we got to a point where no, we can't anymore. We have to invent TPUs. And then we Googled the TPU world. And then we went pretty far with that. And then we said,
Mm.
okay, we've hit all of our limitations. We can't stitch and constrain. We need to go back to the drawing board and reinvent like the architecture. So I think the AI as an industry is grab what's out there, scaffold it together, put it into production. Is it valuable? Is it working? Keep tuning that, and then say, do I need to like go and make this a research problem and go fine tune, go do a new architecture, or is this an engineering problem and we need to just give it, more context, access to more systems, more tooling, more UI elements for the user to give feedback.
Mm.
Um, and there's definitely not a right answer. It just
So
depends
do
on the
you
industry.
see a lot of because it sounds like that usually is one of the bigger concerns that we get when we talk about this with especially technologists like CTOs, is that spot checking it is very difficult, especially if the context is like massive. If you're talking to it about something simple, like you can spot check it and say, yeah, that doesn't sound so right. But when it's just working off of something really
Yeah.
complex, there's no way to spot check it. So shouldn't this be on the roadmap of like all of the user interfaces on top of any of these LLMs? Right? Like, because wouldn't that make people so much more confident? Even if it's saying,
No,
hey, this is the wrong answer, like, wouldn't that make people more confident?
I think an engineer would say yes. I think most people think they want evaluation, and let's walk backwards. Do you, when you have like your teammates that have like quantitative workflows, do you go in and check all of their work and give them a graded piece of tasking and say, hey, did they do it to this bar? And we have a quantitative metric for this. You have a conversation. That conversation either points you directionally in the right area or not.
Mm-hmm.
Uh, there might be a quantitative metric. I think there's a lot of valuation metric and techniques that are out there. I don't think that's the silver bullet though. Like you can have a perfect 100% accurate model by some evaluation metric, and people still aren't going to adopt this type of work. The same way that you can have someone with like a perfect GPA or some quantitative metric on their resume, and then for whatever reason you're still not going to just take them at their word.
Yeah, and it's interesting too that you wouldn't expect like you have like a fantastic PhD on your team doing a given task. You wouldn't expect him to come to you and say, "Hey, this is a finished result, and this is my confidence percentage on how well I did." Right? I
Yeah.
guess it's just a
Mm.
it's a different way form of interaction, I guess. But okay. I just want to go back a couple topics a little bit. When you mentioned that for different problems, the limitation is different um, when it comes to comparing, say, a context window and or rack space. And I thought of a good analogy here I wanted to run this by you, see if this is a good way of thinking about it. Because there's tasks for which the problem is the memory or the context window that you have to be able to process the task at hand, and there's other tasks in which the challenge is to be able to have a huge amount of data. So let's just say, for example, you're trying to find the largest prime ever discovered. That is a very memory intensive computation. You really don't need data, right? You just basically compute and then you keep memory of that computation and then you handle that computation as it grows in complexity. An alternative to the one in which the challenge is the data search space is, I don't know, crawl on the web. The specific data is like very, or service search results. The specific data, the specific task at hand is very, very simple. You probably don't need a lot of RAM, but you need a massive search space to be able to serve meaningful results. Is that a good kind of analogy here to think about it in terms of data versus memory, context window versus RAG?
Probably. I'd have to hear the question, like the topic, but yeah.
Okay. And then on this note again, you mentioned that the challenge again is to be able to understand when a model is hallucinating directly, right? And an interesting idea that you mentioned is that you're kind of like setting up an adversarial architecture in which one model is generating, the other model is grading.
Yep.
Have you seen any other approaches to be able to rate or identify hallucinations, other architectures that are working well? Because what I'm really getting from this conversation, and I think this is a good takeaway for any listener, is that a good way to start thinking about agents or AI applications in general is building blocks in which different
Yep.
models are good at different tasks. You can have agency behavior in all of these different models interacting with one another to accomplish a given task. Different business units, different chips, all to achieve a specific task here. But then again, going back to the idea of the architecture, have you seen any other good architectures to try to identify when a model is hallucinating or when a model is hitting some other level of limitations other than just the adversarial piece?
Absolutely. Everything that
Hmm.
humans do. I think if it's such an easy solution if you just fold back into like how you solve it. So, for example, if a classic one is people generating SQL, like there's a lot of SQL agents or data analysts and a box agents. You can generate the SQL. Easy way to validate it. Does it run? See, does it run? If it does, that's slightly more verified. Look at the results. Did the results look correct? Another one is you said web research, and maybe you ask a question, how old is Messi? It pulls back the information, and you're like, great, I have the result. How would you verify it? You'd probably say, go out again, find a different source, and then if that source corroborates your point, that's verifiable. So I think if you kind of fall back on like how humans do it, we found ways to do this sort of work, and it works. So I think like the first option I always look at is like, how do humans do it? Can we turn that into an agent? And then after that, there's like other fancy techniques. One I'll share with you that we use is there's a company called Grok, which is known for just extremely, extremely fast inference. So what this does is if the problem set is that generation's hard, but verification's easier, not easy, but easier, can you generate 50 attempts at the answer that are a higher temperature? So you're kind of creating some level of variance in the outcomes. And then you have a separate model, then check all the work of those 50 and pick which have the highest consensus, which are likely right, because generation's so quick and so cheap or so parallelized. So that's like a very architecturally specific answer. But there's a lot of decisions around, and that's how people probably do that in their head, right? They're thinking, I could do this, I could do that, I should do this. But when they hear the right answer, it's a little bit easier for you to hear 3 different approaches and then pick the right one than it is for you to generate those 3 approaches. Similar for these agents, they can pick 3 different workflows, 3 different outcomes, 3 different plans, and they're pretty good at picking the right one of the 3 and telling you why. And I think if you lean in on that, you can parallelize the generation and then use the verification workflow, which is typically an easier one for the LLMs to do.
It's funny, like we keep going back to the same thing that is very domain specific. So you want to verify the result of a given model. If the model is generating code, the answer is, does the code compile? If the model is generating responses about the blockchain, the answer is, oh, is it actually exist on the blockchain, right? And so on and so forth. So doesn't that, like, it's interesting because there's so many domain specific pieces to to this discussion about agents and the way that models are interacting with one another and the architectures that you pick, doesn't that make you not necessarily bearish, but doesn't that make you a little bit more skeptical of how close we are to one model to rule them all, like an AGI type model in which a single model can perform and act across multiple use cases and verticals?
No, because humans can do it, right? Like as a human, I have some level of transfer learning from when I worked in industry A and I'm in industry B, and just by seeing a similar problem set, I can reapply some reasoning or logic. And I think you're right. If we only had one shot agents and models, which is like you get all of your perception, you get to think, and then you got to give me an outcome, and I'll grade you on that outcome. That would be probably hard, and that'd be like that's a one model rules all world. In a world where you don't have to have a one shot solution, you can make an attempt, generate a bunch of attempts, verify, self correct, re-perceive, test the action, take a new action. Then you can do what's called an exploration workflow, which is what AI was heavily invested in. This is like reinforcement learning. What's OpenAI did a bunch of good work here as well, where you have some environment and they learn the environment by playing, by taking actions. And the more actions you have to take in the environment, the more reasoning and more knowledge you have, and the better your ability to take the next action. So simply by having a okay agent that is allowed to play, allowed to interact with his environment, it could learn enough over time that it doesn't need a high reasoning, high functioning underlying architecture or model to get there if it has enough compute and memory to play,
So
which is
long
what we
as
do too, right?
so long as the
Yeah.
problem is well defined, right? It's well constrained. Like you're telling the agent, hey, go play hide and seek in this virtual world that I created to you. But you take that model out and say, hey, go drive. Uh, it's the context switch is not there yet, right? So I agree. I'm not saying that it's not possible. We
No, it
It
is.
could though.
Yeah, it
You
could
just
be,
gotta let it
right?
play.
Yeah, it could be. So it'll take what it learned from hide and seek, and maybe it doesn't apply 100%, but the first 40% is the same concept, and then the next 60 it plays and learns. That's what humans do. Is I think that was Brendan's point, is that when we switch
Yep.
industries, it's not 100% overlap, but the 40% gives us enough of a head start that we can fill up the rest.
Yeah.
so it's mainly about
Rate of
shortening
rate of learning.
shortening the rate
Rate
of
of
learning
learning, yeah.
by just throwing more compute at it. Basically, say, hey, instead of taking you, I don't know, 18 years to go from hide and seek to driving, or
Yeah.
not necessarily 18 years, but whatever amount of time it took you to drive after you learn to play hide
Yeah.
and seek, do it in a day by using a lot more compute than what we can use.
This is probably nature versus nurture. Is it just a better
Yeah, yeah.
model that doesn't learn as fast, or is it a shittier model that has a better teacher, a better architecture, and is able to learn faster? Maybe we're going to make that same philosophical discussion about agents. What's a better
So,
agent? One that's able to learn more, learn faster, but it's not a strong model. Yeah,
so you
yeah,
think maybe now the modular agent architecture that a lot of companies are exploring for a specific use cases is limiting what a model can do and building constraints around what the model can do to achieve a specific business outcome. But then the world of research is mainly on removing those constraints and just letting a model play around multiple environments. Is that a good way to put the two contrasts here of a well
I think
constrained, well defined objective and research?
generally, I think yeah,
Okay.
research tries to solve it at the model layer, and then industry tries to solve it by just like stitching, making an engineering problem broadly. Yeah,
Curiosity,
So
Brandon, would you ever go into research? Just would you ever just want to do it?
absolutely not. I power to those people, but I don't have the patience to pontificate around some solution and then not see it through. Uh,
Yeah.
but
Okay. Well,
could you
yeah, so
me.
before we move on, I'd love to understand, Brendan, from your perspective, like one agent framework platform that you've seen that exceeded your expectations, and one that a lot of people have a lot of expectations from, but there's a lot of limitations to it, that was like
Ooh.
underwhelming.
We'll pass it to Sam. I got to think for a second. Sam, something you've been pleasantly surprised and still disappointed about in agents? I have to think about that.
Yeah. So to be honest, I haven't played with that many agents so far. I've been doing the agency piece a lot. I'm using models heavily for perception, for reasoning. But I think something that I'm not necessarily disappointed, but I think there's an interesting gap to be closed there, is access to tooling. It's really easy to call an API. It's really easy to uh, make some clicks on a website, but when it comes to actually be able to exert agency over the world, in multiple domains, from driving to playing chess to taking care of your kids, it's there's a long ways to go. Or even and even something more specific to my area of work in crypto, there's a long way to go from being able to give a model the ability to act agently on the blockchain. There's actually a company, a really interesting company, for anyone interested on looking into this, called Morpheus AI. Morpheus AI is trying to build on-chain agents.
Hmm.
So basically, LLMs that have access to blockchains, permission smart contracts, that they can act within a given problem set. But I think when the problem set gets very specific, and the tools that you use to interact with the problem set are very specific, either online or in the real physical world, I think there's a massive gap to be closed there in terms of tooling to exert agency over the world.
Mhm.
I think perception um, is also not necessarily lacking, but I think perception of non-digital pieces of data is also,
Mhm.
or larger pieces of digital data, is also something that needs work.
Mhm.
But I think reasoning is absolutely fantastic, and I'm mind blown every single time that I go interact with Claude or
Mhm.
GPT-4 or
Mhm.
Gemini.
Mhm.
Um, but yeah, that's my answer.
I'll have I'll rephrase it just because it's an easier one for me to answer. Is what's underhyped and overhyped
Sure.
in
Yeah, that's
agents right
even
now?
better. Yeah, that's fine.
Is I think underhyped. I said at the beginning. I'll say it again. Is like the UI. I think we're a lot of engineers and time is spent into tricking it, giving it better RAG, figuring out how to expand its memory, and all of these like high reasoning and architectural decisions. And if you just show it in the UI, there's a feedback loop that really makes this thing hum. And then what I'll say is overhyped is fine tuning. I have yet to find a single company that has fine tuned a model and not regretted it
Mm.
in like 2 weeks, 3 weeks tops.
Interesting.
Like by and large, I can maybe think of one or two that it actually made sense, and it's typically like the actual foundation model companies, like the actual foundational LLMs, to make function calling easier, instruct tuning, like those like are kind of like broadly making use.
Mm.
But fine tuning overall has not produced value because every month a better model comes out that is a general purpose model that significantly outperforms whatever you just fine tuned. And I'm sure like that will reach a saturation point, but we're 2 years, 2.5 years in, and fine tuning is not producing value. There's some odd exceptions. I'm sure someone will call it in the comments, but um, typically you don't need fine tune. Not yet.
Do you think RAG is overrated or underrated or properly rated?
Properly rated, probably depends on the use case. But I've never found one fine tuning that makes
Mm.
sense yet. Yeah.
Okay. Well, we're 45 minutes into this conversation, and as per usual, we couldn't get into a second topic. So we're gonna have to push that back to the next episode, hoping the meme coin market doesn't implode by then.
I
But
won't.
for now, we'll leave you with this. Any final remarks, James or Brendan?
Final
Fun.
question. Yeah, final question. I know we're up on time here. Um, is the impact on human workers overestimated or underestimated?
Probably overestimated in the short term, underestimated in the long term.
What do you think, Sam?
I think it's properly estimated. I think things are going to change significantly, and I think we're starting to see that.
And what time horizon?
5 years.
Do you agree, Brendan?
I think there'll be significant changes in 5 years. I don't know if they're because I think the underlying assumption is like the impact means it's a negative impact on human labor. I actually don't know if that's true or not, and I don't have a super strong opinion there. I think there will be roles that probably have high impact in a short time frame that are negative. I think like a great example, which we've heard in another podcast, is architects that do CAD when the computer got released. People that did drafting in CAD, their job was supposed to go away completely with computers. They became one of the most high paid roles, and they to this day still are a great CAD architect using a computer. So it made them able to do twice as much work to get paid, 3 times as much money, and they're still around, 50 years after some of those early computing protocols.
Mm.
So that's one where maybe people thought it would be going away completely, and it just made them better, faster, stronger, and more
But if
more
it
valuable to
did,
society.
then the number of architects needed went down, or the need of architects went up so much that even though they were 3 times more productive, there was just a bigger need. Like, which of those happened?
Both.
Hmm.
You were able to go from we can only the richest people would be able to like hire an architect and everything else was cookie cutter to the cost to do an architecture drawing came down and the ability to do it's similar with websites. Like I don't think a website developer got paid less in the last 20 years. Like generally speaking, it just went up with better website technology, better tooling. There's just more websites got created and more developers came into the space. And we haven't seen like a saturation point yet. At least I haven't seen it in like developers.
I
Yeah.
in this discussion, and this is a longer conversation for sure, and we can revisit in a future episode. But I just think that the often called argument that AI will create new jobs in the same way that previous waves of technology have created new jobs seems not super applicable to me, or seems
What's
lacking.
one job that you think that wouldn't happen?
Very, very objectively, I think, just to give an example of a job that a lot of people thought was untouched in software engineering, I think QA is going away. I think you're not going to have QA engineers anymore. And I think there's a massive amount of QA engineers that are going to find themselves jobless, and maybe a very few that are going to be extremely empowered by the tools. So I think it's like, to your point, I think it's
That's crazy. I think the exact opposite. I think QAs would 10x in terms of requirements.
Yeah,
Because
because
our
they're the
code is no
ones.
longer
Yeah,
it's not
exactly.
deterministic.
Yeah,
Our code's not deterministic anymore. So you need more QA.
yeah.
but
Because the
I
LLM
think
based system,
I think to your point of I think it attenuates the tail end of the distribution. So basically, the top 1% QA engineers, or for any specific profession, become super powerful, and then they just I don't think the demand necessarily increases unless a specific use case in which it increases. Maybe QA is that use case, or maybe it's a different use case. But I think a bunch of or a small number of professionals in a given area become extremely more powerful, and then they are able to start addressing the demand that was previously covered by a bunch of other people before. And then all the 90%
Yeah,
or
I would agree with
95% or
that. Yeah.
99%
I would think that like
who
basically anybody with less than like 10 years of experience, like they're the most, ready to go, because that's the kind of work that the agents can do very quickly and very, very, really well. But the more experience you have, the more specialized you are, the better off you are at running a team of agents instead of being replaced by the agent. So I think that gap, like university through to being like really good at your job, that's going to be the hardest hit. But the
yeah
people who are like already past that point, like QA requirements, I agree with, but would go through the roof. But
yeah.
one QA, senior QA engineer will be able to do the work of 20 with
yeah
like
yeah
junior QAs being agentized.
I
Uh,
think similar to
See,
the
here
architecture.
I'll give you another scenario though. Think about this. You have a million autopilot robots in people's kitchens, cars across the world. The liability risk taken on a business to not have a human validate when a robot's about to do an action that they have a confidence interval of outside of the norm, they're going to allow that to be an overseas decision to a very low paid person in another country that is currently a lower quality QA agent. That need will significantly rise. I'll give you a very concrete example. If you saw Amazon Fresh, the Amazon
Yeah,
cameras in
yeah,
the sky
yeah.
checkout, that was never AI. That was just
Yeah.
people overseas validating that. There will be millions of agentic sensor perception systems that it is cheaper to hire someone at that rate than it is to get your system to solve that edge case. And as more systems come online, there will be a wave of like QA, which is like human in the loop. Effectively, maybe you don't call that QA. I would call that QA. Of it is cheaper for us to solve this with humans than it
No,
is
but it
with
isn't,
like
right,
a
Brendan?
better
Like the
architecture.
cost of a human hour how is it possible that it becomes lower than the cost of tokens? That's not possible.
No, because it's not confident enough with the outcome. It's not that the tokens are cheaper or more expensive. It's that me walking out of a store, if you have an AI agent which is multimodal and has a camera sensor and it's watching a video, it's using Google's Gemini model, so it's got video, and it's you're walking out of the store and you bought a big flat screen TV, and it's like they didn't buy a TV, they bought a small computer monitor. It is cheaper for you to go and validate that with a QA person than it is to take the agent at its word because the difference in price of someone walking out of the store is thousands of dollars. And that I think exists across every
But I think at
industry
that
where
point,
there's a
But
yeah
wouldn't there still
I
be
think at
like
the point
one
you're,
person can kind of watch over the work of many, many, many agents, right? Because
yeah
you're only talking
but
about
but
the
there's
edge
but there's a
cases.
million more agents there's a million agents that have entered the market. There is every single grocery store has this system. So for a great example is like Scale AI. When self-driving started, they created a market of over 100,000 labelers around the world because self-driving was an industry. Those 100,000 labelers did not exist before Scale AI was invented. Scale AI was invented to effectively fill the gap of data labeling for self-driving cars. If there is another wave, which is agents, there is a QA gap that will exist somewhere, somehow, and there will be a mountain of people of varying skill levels required to fill that
But
gap,
wouldn't that
either for
labeling
training
be
data
done?
or for
But labeling is finished or has an end to it. Like it's not like a forever task to just keep labeling more data.
and I think you're also assuming at
it.
that point
It
that the
It
is.
model is not
is.
going to continue to improve. I think like
Depending on what your use case is, right? Like
but
think
We
think
need
about
a
it.
whole
It's
we need
it's
a whole episode on the impact of
yeah, we do, we
AI
do. We
on the
do. We do.
workforce because like this is
Yeah,
this is probably the biggest topic I think in people's heads, right? Like
yeah,
all the way
yeah,
from
yeah,
government to CEOs, they're all
yeah,
like, okay, what does this actually mean for humans? And so we
yeah,
can't
yeah.
do it in 5 minutes, I don't think.
yeah, yeah.
I agree, I agree. Let's table the
Fun.
Okay.
discussion.
I love
I'm
it. I
gonna
love
call
I
it
it.
love it.
here.
Yeah.
This was
All
good.
right.
Great chatting, guys. Thank you
See you,
all, and we'll
boys.
see
Thank you.
you in a few weeks for the next episode.
Absolutely. Take care.
Peace.